Welcome to EnfinityCast, the show that explores the science and technology shaping our future. We talk a lot about generating clean energy, gleaming solar panels, massive wind turbines, but what happens when the sun sets or the wind stops blowing? That's the multi-trillion-dollar question, and the answer lies in storage. I'm your host, Elion Quanta, and here to help us unpack the breakthroughs in battery technology is Zia Monroe. Welcome, Zia.
Thanks for having me, Elon. It's great to be here. And you're right, storage is the linchpin. Without an effective way to bottle that energy, a fully renewable grid remains just out of reach.
So let's start right there, this problem of intermittency. From an analytical standpoint, why is it such a fundamental hurdle for a modern power grid?
Well, our grid is built on a delicate, real-time balancing act between supply and demand. Power plants, historically fossil fuel plants, can be controlled. You can ramp them up or down to meet demand precisely. With solar and wind, you're at the mercy of the weather. So you inevitably have periods of massive overproduction and periods of shortfall. The only way to bridge that gap is to capture that excess energy and save it for later.
Enter the battery. And for the last decade, the undisputed champion has been lithium-ion technology. It's in our phones, our electric cars, and now in huge grid-scale installations. What made it so dominant?
It was really the perfect storm of factors. It has a relatively high energy density, meaning it packs a lot of power into a given weight. And critically, the massive scale-up for the consumer electronics and electric vehicle markets has driven its cost down dramatically. It became the default, affordable, good enough solution.
But good enough doesn't sound like perfect. As we try to scale this up to power entire nations, what are the limitations we're starting to see with lithium-ion?
There are a few key challenges. First, materials. Mining the required lithium and cobalt has significant environmental and ethical concerns. Second, safety. The liquid electrolyte inside them is flammable, which can lead to rare but dangerous fires, a condition called thermal runaway. And finally, lifespan. They degrade over time, losing their ability to hold a full charge after a few thousand cycles, which is a problem for infrastructure that needs to last for decades.
This feels like a natural pivot, then, to the next frontier. I keep hearing the term solid-state battery being called a game changer. What exactly is it, and why are scientists so excited about it?
The innovation is right in the name. A conventional lithium-ion battery uses a liquid or gel electrolyte to shuttle ions back and forth. A solid-state battery replaces that flammable liquid with a solid material, often a thin layer of ceramic or a specialized polymer.
And what does that simple-sounding swap actually achieve?
It changes almost everything. By removing the flammable liquid, you make the batteries incredibly safe. It also allows for new chemistries, like using a pure lithium metal anode, which can dramatically boost energy density. We're talking about batteries that could store twice the energy in the same amount of space. And they promise a much longer lifespan, potentially lasting tens of thousands of cycles without significant degradation.
So, more power, safer, and lasts longer. That does sound like a holy grail, but when does it leave the lab and get plugged into the grid?
That's the big question. We're seeing a lot of successful prototypes and pilot programs. The main hurdle now is manufacturing. It's incredibly difficult to produce these solid electrolyte layers perfectly, at high speed, and at a cost that can compete with mature lithium-ion technology. Most analysts are cautiously optimistic for widespread commercialization in the late 2020s or early 2030s.
So the takeaway is that the race to a clean energy future isn't just about building more solar farms, but just as importantly, about perfecting the jar we use to store the sunshine. The innovation happening inside these batteries is just as critical as the turbines turning in the wind.
Exactly. The unsung hero of the green transition is the battery. The breakthroughs happening here, from solid state to other chemistries like sodium ion or flow batteries, will truly define the energy landscape for the next generation.
Zia Monroe, thank you for making that complex topic so clear. That's all the time we have for this episode of EnfinityCast. Join us next time as we continue to explore the frontiers of tomorrow.